All right, so welcome everybody. Welcome to Origin and Causes webinar titled Marine Fire and Explosion Investigations. My name is George Gastandi and I will be the moderator today. I just wanted to go through a few things, but first, I hope you and your families are in good health and in safety, enjoying the last couple of weeks of the summer before school starts in whatever form in your area that takes, and just regular September life. So let's kick it off. I wanted to go through a few things. First, with regards to the Q&A, we're going to have a Q&A at the very end of the webinar, try to get to as many of the questions submitted as possible within the hour time. You can submit your questions in the box, in the GoToWebinar box right here. Just input your question and we will try our best to get to as many questions as possible. Any questions that we don't get to within the hour, we'll follow up with you after and send you an email and answer those questions. All information that's being discussed in this webinar is for educational purposes only and should only be applied directly to the administration of a claim with consultation with a forensic expert. So if you think you've learned something that applies to a file of yours, we strongly suggest you call a forensic expert that you trust and have a discussion. Make sure that the action that you're about to take does apply and it is being applied correctly and in your best interest. The webinar is being recorded and is going to be posted on our website, on LinkedIn and YouTube pages, so please feel free to pass them to your colleagues and use them in your team meetings if you wish. We're going to be sending completion certificates after the webinar. It'll probably be mid next week, and so just stay tuned. We will be sending those by email. And at the end of the webinar, when you close the GoToWebinar window, you're going to be prompted to answer a few questions. I think it's 5 questions about the webinar. We'd love to hear your feedback, your ranking of our speaker, the content, and so on. If you're having any technical issues, experiencing any technical difficulties, please email us at webinar@origin-and-cause.com. So now I'd like to introduce to you our speaker. We have Richard Curran joining us today. He's the Vice President of Origin and Cause, as well as a practicing forensic engineer. He has over 30 years of experience and has conducted over 3,000 fire and explosion investigations. He's been accepted and testified in court as an expert witness over 40 times across Canada and internationally. He is a Canada coordinator for the International Association of Marine Investigators and lectures across Canada about the subject of marine fires and explosions. He specializes in chemical engineering, as well as product liability investigations, residential, commercial, and industrial fires, wood burning appliance failures and such claims that relate to wood burning appliances, marine related fires and explosions, fire suppression systems, and fire department litigation. So I'll pass off the mic and the screen to Rich. Just excuse if you see a little bit of a fidget on your screen. We haven't lost you. So Rich, the invite should be on its way to you.
Yep, I've got it. Thank you. Welcome, everyone. So, in any forensic investigation, you must first zero in on the origin of the incident. And within the place of origin, you will find the cause. A lot of people use the term origin and cause and origin interchangeably. But to be correct, and I'm going to correct that today because it's technically incorrect, you determine the origin and then the cause of the fire. In this webinar, we'll go through the investigative process of a forensic engineer specific to marine fires and explosions. And it'll become clear as to why there's no such thing as finding the cause and then the origin. its origin, then cause. So first, finding the origin. How do you determine where the fire originated? Even in a structural fire, no different. You work from the least damage to the greatest damage. You complete an exterior examination on a boat. That's not sometimes always possible. And then you complete an interior examination. There's no trend in a marine investigation as to the extent of damage. Same as a building fire. You can have a house that's completely intact with a small confined fire, or a square burn pattern, as we call it, where there's nothing left but the foundation. So here's an example of a relatively undamaged boat that has sustained a fire loss. Here's something that's a little more typical of a marine fire. And there's an example of a total loss. That's all that was left of the boat. So information to consider in all marine fire investigations. 1, time and place of the boat fire. Is the boat at a marina or is the boat in an isolated area? Time of day. Is it in the middle of the night or middle of the day? Beginning or end of boating season? These are questions to think when you're getting a loss. Physical evidence, what we'll be looking at in the photographs as we go through this, but we're looking at char patterns. Now, most boats are not wood anymore, but you still get them, and there's still wood on boats. So we're looking at char patterns, no different from a house or a building fire. Fiberglass delamination. With fiberglass, it's the epoxy resin that burns, not the fiberglass mat. So we're looking at how many layers of fiberglass have delaminated. It gives you an indication of how long the fire is burned. Again, no different from a structural fire, the area of lowest burning. We're looking at heat patterns. Again, no different from a structure fire. We're looking at discoloration and melting of metals and melting of plastics. These are all indicators of proximity to the fire and direction of fire. Most common causes of fires. Here's the basic 2 categories. We have accidental, and under accidental, we have fuel related. Number 2 is electrical related, or 3 is other causes. And of course, then non-accidental arson. Under accidental causes, fuels, you can have a varying degree. Most boats are gasoline, but some boats do have diesel engines. And a lot of bigger boats now, it is not uncommon to find propane. This is not fueling the engine, but this is for the toys. The propane barbecues that are sitting on the boat or hanging from the aft rail. Older boats used to have alcohol cooking stoves. That's more or less gone by the wayside, but there are some of the older boats still have them. And then you can have an engine oil fire. Under electrical, you typically have one of 2 electrical sources. You have 12-volt DC, which is the onboard electrical batteries. And as most boats have shore power, you have 120-volt AC, but you can also have a generator on board the boat, which will produce the 120-volt current as well. Under other causes, you can have spontaneous combustion of rags soaked with teak oil, fiberglass laminations. It's a chemical process. It generates heat, and if not done properly, can cause a fire. Obviously, you could still have smoking materials. And on boats, there are some other maintenance activities such as welding, grinding, or even working on the engines for various reasons. So here's our first accidental cause. This is an electrical fire. This is a 30-foot express sailboat. In a nutshell, the owner of this boat lived on the boat, worked in downtown Toronto. departed the boat first thing in the morning, and sometime later was notified that his boat had caught fire. Now, as you can see from that photograph, there is not a lot of damage to the exterior of this boat. It pretty well self-extinguished, fortunately. But if we look at the hull hatch or the hatch into the cabin, you can see there's some heat deformation, there's smoke damage, all in the area of the hatch cover. No evidence of fire on the aft deck area. It's pretty clean. Now we're looking at, on the aft deck area, a sail, what's commonly called a sail locker. And you can see on the underside of the hatch cover, there is quite a bit of smoke. So there's an indication that the fire has migrated into this area at least. Now we look a little closer into the hatch area, and you can see that metal box here in the middle of the screen, and that's a junction box. Now, we're going to raise this point a little further later, but is that appropriate for a boat? And we will see why. So now we're looking into the cabin area of the boat, and we're looking forward towards the bow. You can see this gentleman's housekeeping is not the greatest, but you can see forward, there's primarily smoke damage, very little heat. Now we're looking aft, and you can see the hatch on the right side there, leading to the aft deck. And you can see here, we've got a lot of fire centered around this bulkhead. Now, question arises, what is this? What are these various items? We look a little closer, and on the left side, you can see there's a breaker panel for the DC current. This center orange dial is called a battery switch. It switches between, in this case, two batteries. You can be running off, you can turn it off, so they're not running on any batteries. You can run off one battery, or you can run off two. And to the left or to the right there is a radio. Now you can see this battery switch has sustained some fire damage, but the greater damage is to the right of it. Now we're looking at the battery switch here in this photograph. As the top of it, and you can again see there's major exposure fire damage to it. There's the back side. Again, exposure fire damage, no evidence of any internal failure. And there's our junction box. Now, what is that junction box being used for? Well, closer look, and we see it is a receptacle box. And if you'll note, in the upper half of the receptacle, the owner has actually taken a normal 14 gauge NMD electrical cable and spliced it to a plug and run off to some area. In the bottom, which has suffered less fire damage, you can see there's a standard electrical cord. Now, I don't know if you noticed in the previous earlier photographs, you saw a microwave oven on the boat, which was he was using as one of his cooking sources. Now we're going to look a little closer at this receptacle. Now we've opened it up, and you can see the upper half is not badly fire damaged. The lower half, the Bakelite material, has disintegrated, and you can see a nice big glob of copper there and a glob of copper down here. You can see this is the center of the electrical activity in this case. Now, when we look a little closer at this plug, the bottom plug, you can see that one of the prongs is actually melted right off. The other half is still there. But notice the green oxide on it. Now, again, because this box, this junction box, is designed for a house, not a boat, it's not watertight, it's not moisture resistant, and boats, being boats, are not 100% watertight on the exterior. So moisture has infiltrated into this receptacle box over time, built up corrosion, and that corrosion has now become conductive, and we've had an electrical failure resulting in this fire. So take home points from this little example. Boat owners commonly make their own modifications to their boats. They don't like having people sometimes do the work for them when they can do it themselves. It's cheap. They don't always use the proper materials. As an adjuster, it's crucial to preserve the evidence at the scene. And as an adjuster, you need to ask these questions. Has the owner had any repairs done or modifications done to the boat lately? And if so, who did the work? And regardless of who did the work, obtain detailed statements to protect yourself from liability. Now, as any lawyers being present in this webinar, you need to make sure some of these points are covered off too, if we're going to litigation. So now we're looking at a second example of an electrical fire. This is, again, not an extreme. You can see this boat, very, very large 47-foot Catalina yacht. It's an older one, 1999. This boat had actually sailed across the Atlantic. It's that capable. History on this boat, the gentleman had it winterized. It was onshore. Now, in the next photograph, you can see the boat looking out toward the lake. So you can see it's in an exposed area. So wintertime, it's going to be subject to a lot of winds, which is an important factor in this loss, and just the weather environment. Now, again, you can see aft deck area, very, very minimal damage. There's nothing really obvious. We look a little closer at the hatch again, going into the cabin, and you can see that the plastic bags that he's used to seal up the hatch cover have melted, and you can see a lot of soot around the opening for the hatch. When the gentleman, the owner of the boat, went to open up or get the boat ready in the spring, he discovered there had been a fire. Again, because everything was closed up, the fire self-extinguished. Now we're looking down into the hatch, and you can see the ladder going down, and you can see a lot of soot and carbon deposits inside the cabin area. Now again, looking forward, you've got a lot of soot and heat. Upper level, the ceiling, the plastic and fiberglass have started to be subject to thermal degradation and crumble. You can see plastics melting. So we've got a good indication that there's been a lot of heat in this boat at high level. But as you can see, it's decreasing as we go to the floor. Again, but soot, there's soot everywhere. Now we're looking towards the aft, or the rear of the boat. And on the right side, you can see the galley area. Again, heat and smoke, high level, decreasing towards the countertop. On the left side, you can see there's obvious charring. This is obviously where the fire originated in this general area. On this boat, this area was known as the navigation table. So looking a little closer, now we can see all the equipment that's in this area. Radio, a lot of other equipment. All the electrical is concentrated in this area. And again, you can see the fire damage is extended down to the base of the seat and then progressed upward. Now we're looking at that lower section, and you can see some items, contacts. Again, note the orange, and based on the previous boat fire, that's an indication that this item here was the battery contact switch. Okay. Now we're going to look at, okay, so the question is, did this fire start outside this area or inside. So we're going to look at this little piece of wood here, and you can see that on the outside, the plastic cover has melted, but there's not a lot of charring. On the inside of that piece of wood, you can see the deep charring, clearly indicating that the fire has originated within this area of the boat. Now again, the cover is taken off. We can see more clearly the large number of wires, electrical cables routed in this area. The large diameter cables are actually the battery cables. And so again, you can see these parts are all part of the battery switch. Now we're looking a little closer, and again, you can see the green oxide. In this case, it's not from water, unlike the contact on the plug, but this is just because the copper wiring has built up with heat and then oxidized, and because we don't even know when this fire actually took place, the oxidation has been occurring over time within the boat. But you can see this heavy cable has actually been severed. And you can see numerous other wires that are severed. There's wires, smaller gauge wires are all severed, and these would all be going to various parts of the boat for the 12-volt DC electrical system. So there's one of the battery cables. That's the end that would have been at the battery switch, and you can see this wire has been severed. So the boat's on shore. Why would there be an electrical power? There was no extension cord running to it. And lo and behold, we lift up the hatch covers in the galley or kitchen area, and we find two very large, or more than two, large 12-volt batteries, all connected. So this boat had live 12-volt power all the time, even when it's on dry land in the middle of the winter. Why is a good question. So is it a good idea? There's no need. You're not running bilge pumps because it's keeping the bilge empty of water. There's absolutely no need for this boat to have electrical power. Now, again, going back to an exterior shot of the boat, notice the mast is in place. Is this a great idea? This mast may not have been one that could easily be taken down in the wintertime. It sat on top of the roof cabin. It didn't go all the way down. So yes, it could, but it's a big mast. But think about it, wintertime, strong winds, what is that mast going to do when subjected to extensive high winds? It's going to shake. And that's vibration is going to be transferred through the boat. And those wires are going to be shaken around. They would have been, if the boat has sailed across the Atlantic, it's also going to have been banged around. So the wires are actually rubbing together and have been rubbing together for quite some time. And it just finally, they shorted out and we had a fire. So again, when boats are placed in winter storage, all electrical sources should be disconnected. There's no need to have an electrical source or live electrical on the boat. So questions you need to ask when you receive a fire for a boat in storage. Was the boat winterized? Again, if so, who did the work? Many boat owners will winterize the boat themselves, again, because it costs money to have somebody do it. And again, if they did do the work themselves, have them explain what they did for the winterizing. Were the batteries disconnected? And in this case, could the mast have been taken down? It's something that may have been practical, it may not have been practical. Okay, moving on. We have another accidental cause, and this time it's a fuel explosion. It's a 1986 25-foot DORAL citation. A very brief background. The current owners had purchased this boat quite recently. No problems with it that they knew of. They were refueling the boat, and after refueling, they went to start the engines. Now, whether they ran the bilge fans long enough to evacuate any gasoline vapors, which they're supposed to, it's not known, or whether they ran it long enough. And anyway, the boat had an explosion. You can see the boat is relatively intact overall. Now, this is the location where the explosion occurred. You can see the fuel pump here in position, and a little closer face, you can see the glass of the fuel pump is cracked from the force of the explosion. It wasn't a major explosion. Looking closer at the boat, you can see that the hull has separated along this line. The hull is separated from the upper deck area. And you can see glass is cracked, and that's just on the one side. There's a closer view showing the broken glass. So there's been a push. Fortunately, nobody was hurt in this incident. So now we're looking at the aft, or the stern of the boat. There's the engine compartment, and you can see there's no evidence of damage below, but look at all the other items. Look at the railings that have been broken off and separated. This little console here has been displaced because obviously the porthole window would not normally, this would not be sitting blocking the porthole window. So again, giving an indication of the push that took place. And again, we've seen the railing, it is actually lifted upwards and it's cracked and torn the deck. This is looking inside the cabin, and you can see that the explosion has actually blown into the cabin and displaced the steps. And you can see a lot of displacement, delamination of plastic due to the flexing of the hull. Again, looking at the engine compartment, there is a bit of heat damage here, and you'll see there is a bilge fan duct there that's spiral wire that's covered in plastic, and it is melted off. But no obvious sign of fire within this area. But the ignition source did occur down here. So again, looking at this area here, this was actually a little door that allowed you to step into the aft deck area from the swim platform. So we're going to look closer at it. Now, again, this would normally be all concealed. So the red line here is your fuel line. That's where you're filling the fuel tank up at the pump. And you notice there's masking tape around the hose. And a closer look, you'll see there's a clamp on the fitting. So that fuel line is firmly secured. Why this masking tape was there, we think it was used as a seal, but the current owners didn't do this. Now, we're looking below that area, and again, there's your fuel line. This fitting here is the vent line for the fuel tank. So when you're filling up your fuel tank, gasoline vapors and air are being pushed out of the fuel tank. They're being displaced. They've got to go somewhere. So rather than let them go into the engine compartment, there is a line that directs those vapors and purges it on the exterior of the boat. But the question here is, where is the line? Well, there it is. A black rubber hose, no hose clamp, and masking tape holding it in place. So in this instant, what we've had is that the clamp or the fuel line or the vent line has come off at some time. And of course, when the boat is now being refueled, those vapors, instead of being vented to the exterior of the boat, are accumulating or venting right into the engine compartment. So again, lesson to be learned. So take-home points. When purchasing a used boat, it has risks, and so does insuring them. And questions an adjuster need to ask: where and when did you buy the boat? Obviously, was it previously owned? If it was previously owned, did you have a marine surveyor examine the boat? A marine surveyor is like a home inspector. I think they do a little more thorough, but they look at the hull, they look at everything, and they give the buyer an assessment of the condition of the boat. Now, again, whether a marine surveyor would have seen this because it would have required removing some things, but I know that marine surveyors do a pretty intensive job. And again, was there any recent or past service work done that the insureds know of? And again, if so, who did the work? Important points to know. So moving on to another fire. This was again fuel related, but it ties into workmanship. Now, this is a 2001 Carver 350. Brief history on the boat. The boat was, the owners were sailing the boat from Georgian Bay, across Georgian Bay, from Killarney, Ontario to Manitoulin Island. And en route, they lost power in one of the engines and limped to Manitoulin Island with one engine. They tried to get a mechanic pulled into a service area, marine mechanic. They didn't have room to hold the boat, so the boat was then taken to a public marina owned by the municipality and docked there, and the mechanics came to the boat. They began working on the engines, and while they were working on it, suddenly there was a fireball that went through this boat. Fortunately, the occupants on the boat all got off safely with no injuries, but of course the boat was destroyed. Now, the boat as you see it is not how we first saw it. This is how the boat was originally found. The municipality had kept water pumps going on it because of course the fire department are dumping water onto this boat to put out the fire, and it's going to sink. So they had kept pumps on it, but unfortunately they had to stop, and the boat did sink. We then brought in commercial divers and airbags and pumps, and it took a good part of a day to get this boat back to a floating condition. And again, you can see now how much damage to the boat there is on both. There is no cabin, and there's fire damage on the hull. This is a closer view of the forward area of the boat. A lot of fire damage. You can't even recognize there's no cabin superstructure left on this boat. Another view of the cabin area, forward cabin area. So as I said, totally consistent with a fireball moving through this boat. So now the boat is on dry land, and we can safely begin our examination. Again, exterior shots of the hull. Unfortunately, because there was a bin placed on the other side, we couldn't get a shot of the other side of the hull, but we did have one when it was still afloat. So now we're looking at the aft, or the stern of the boat, and this is where the engines are located. And this boat happened to have an aft cabin. So the main salon or main bedroom was actually located above this area of the boat. Now, closer view, the two engines, and you can see the port engine here and the starboard engine here. And you can see there's quite a bit of difference in damage to the two engines. There's a closer view again. Here's the starboard engine. The fuel tank is relatively undamaged. Carburetor and filter are still in place. Fuel lines are not too bad, or coolant lines and everything are not too bad. We look at the port engine. You can see that the port engine fuel tank is partially melted. Extensive damage to the engine, the top of the engine. The carburetor is completely gone. A closer view. So what we're looking at, again, number one is the carburetor, what's left of it. Number two is the fuel rail. This is a fuel injected engine, like a car. And the fuel rail runs on both sides. They're interconnected, and pressurized gasoline is distributed in the fuel rail and then injected into the cylinders when required. Now, on these fuel rails, there is what's called a Schrader valve. And the Schrader valve is used like it's a bicycle tire, your fill line on your bicycle tire. It's to bleed air out when the system is being originally set up or work is being done on it. So now we're looking again. Here's the starboard engine with the Schrader valve as it's supposed to be. Here's the port engine, and you can see there's an object on the Schrader valve. And the question is, what is it? So closer look. Here is the parts still attached to the fuel rail. And you can see this is still all part of the components. We haven't taken it all apart. Turns out what we had connected to the Schrader valve was this. This is a pressure gauge. The mechanics that were working on the boat at the time had hooked up this pressure gauge to the fuel rail to monitor, basically do their diagnosis and figure out what was causing this engine to run improperly. The question or the problem was, one mechanic was down in the engine compartment, the other mechanic was up at the helm running the throttles on the engine. And then the mechanic in the engine compartment left. And this was just laying on top of the engine. And you can see this large long plastic tubing is for bleeding the air off the line and seeing that gasoline is actually coming out. And it's our opinion that this component fell off the engine, got tangled up in the pulleys while the engine was running, and of course ripped off. And this is the part, this hose ripped off of the barb. And now we're dumping high pressure gasoline into the engine compartment, which was ignited and resulted in this, basically a flash fire. So faulty workmanship, improper installations, improper choice of materials used in the installations, or improper choice of equipment used in repairs happen quite often. Perhaps there's no such thing as a certified marine mechanic. There are no regulatory bodies providing formal training programs or licensing for this vocation. It is simply a mechanic specializing in boats based on their exposure and experience to them. Therefore, the quality of workmanship and the repairs done to boats is dependent on the quality of informal training and the experience the mechanic working on the boat has. It's the luck of the draw, basically. So make sure you get as much information about the service work done and the mechanics when receiving a claim. Questions you need to ask: what is the name of the company that did the repairs? The mechanic's information. What components were repaired, replaced, and from where? And were components suitable for a marine application? Again, it's not uncommon. An alternator on a marine engine does the same thing as an alternator on a car, but marine alternators are designed for wet and moist environments as a big difference. So now we have an accidental fire. This is, if you remember back to the beginning, this was a boat that I showed you in the very beginning, you can see this boat is very, very little damage. It's relatively intact. Little background, gentleman owned this boat, was working on it, getting it ready for winterization. There was a flash fire. He subsequently inhaled hot gases, didn't die at the time, but later died. And there was a lawsuit against various parties because of this incident. So, looking at the interior, go back first. You can see there's very little damage. There's a bit of soot around this area here on the boat, but nothing very obvious. So looking in the cabin, there's the helm, this is the main cabin area, no obvious fire damage. We look down into the engine compartment, which is underneath the cabin, and again, nothing significantly. There's a bit of soot, no major fire damage. You can see here, there's plastic over this cover, and you can see it's melted. So there's been heat, not a lot, and definitely not enough to ignite the plastic. So we're down in the boat, in the engine compartment. You can see that work is being done disconnecting the batteries. There's one of the battery cables. There's where it would have been attached. So work is being done by the owner on the batteries. Again, little area, but you can see over here, we have a little red Dixie cup with something in it. You'll see a better picture of it in a minute. But as I said, work is being done on the batteries. Again, a view of the engine compartment upper area, not a lot of fire damage here, but you can see again, bilge fan vents, the plastic is melted off the hoses. Again, just showing you there was heat there, it just wasn't enough to cause ignition and burning. So this was recovered from the scene. What it was being used for at the time, we don't know, but it is the source of this whole incident. You can see the can doesn't appear to be badly damaged. When we actually look at the can itself, if you go back there, you can see the cover. He wasn't actually using it, but you can see the cover is melted. This product was a WD-40 spinoff sold by a large department store. They had it manufactured for them. So this little mark here is actually a hole that is burned through the sidewall of the can. Now you notice this label is painted on, or it's a plastic, but it doesn't cover over the seam. So this is the only exposed metal on the whole exterior of the can other than the base. So there's one mark. There's a closer view, and you can see there's actually a hole right into the can. There's another mark on the base, and they line up. So again, this is an aerosol can. This product used butane as a propellant, which is not uncommon. And of course, butane is a flammable gas. So if you burn a hole through the sidewall of the can, the butane gas is going to come out very, very quickly. And if there's an ignition source, it's going to do it. So how did we create these marks? Well, we measured the distance from the one mark to the base of the can, and it's 5¼ inches. When we measure the distance between the terminal posts on the battery, 5¼ inches. So everybody, the consensus was that the can must have fallen down, and just by luck of the draw, I mean, you've got almost 360 degrees of protected surface, but the 1 5-degree area or narrow strip of unprotected metal made contact with those batteries. It's now an electrical short. It burned a hole in the can, and as it rolled off, the parting spark ignited the butane gas and resulted in the incident. So humans make mistakes. Some have more dire consequences than others, in this case, fatal. The nature boats having confined areas make it difficult sometimes to do the most simplest of tasks. Therefore, human error claims such as these are not uncommon. Questions you as an adjuster or a lawyer need to ask: focus on the insured, their actions, their background, their experience. A lot of times we run into claims where the insured is a contractor or mechanic and simply want to do the work themselves. Some people feel their technical background is transferable to a marine environment. I think if you have that in a statement, it helps to bring context to the story. If they purchased any products, find out from where, and if by any chance they have receipts, get them, because there may be a product liability claim. So moving on. This one is a little different. It's a manufacturing defect and some workmanship here. But this was a brand new boat. The owner of the boat had only stepped on board it once, had never operated the boat, had bought it from a sales agent. The boat was then built in China, was purchased for $600,000 US, and by the time he added all his toys and several trips to China as it was being built, it became $1 million boat. The boat was being sailed across Lake Ontario by the sales agent and his captain. After work was done in the United States on it, fire suppression system was installed. The hull was repainted. There's some other repairs done, and they landed in Toronto at the On the Water Boat Show. It was going to be on display, and discovered a fire. So again, you can see not a lot of obvious exterior damage. Look inside the cabin. There is evidence of some damage in here. Definitely the fire has migrated up from the bench area, from the area below, into the cabin area. So obviously the fire is down in the engines. Now we're looking down through a hatch into the engine compartment. It's one of two access points into the engine compartment. Looking inside the engine compartment, and you can see the two large diesel engines. So these are diesel. The engine on the right side of the photograph has obviously sustained more fire damage than the left engine. Looking a little closer, you can see a lot of fire damage in this area. This was also where the battery switches were located. Also, and you'll see it in the next photograph, here is the fire suppression system that was installed at a marina in the United States before the boat was brought back. And again, you can see there's quite a bit of fire damage in here. This system should have automatically operated, put out the fire before it reached this stage. We're looking at the fire extinguisher itself. Now, the circle here is where the manual cable, which is this part here, hooks up to a glass bulb. And if you pull a handle, you can break the bulb. But automatically, that bulb will break. It's filled with liquid, and the bulb will break when it's exposed to fire, causing the fire suppression system to discharge automatically. Now, again, you can see the gauge is destroyed, but we waited after the fact and we confirmed that the cylinder was empty at some point in time. But whether it discharged properly or not is another question. So here's a view of the top. And again, there's our glass bulb, and you can see it's not broken at all. It is completely, it appears to be intact. And this little device here was actually looped into this tab. So this, aside from preserving the whole boat, this cylinder was removed to be preserved as evidence. When we looked at this with the fire suppression system manufacturer more closely, Again, it doesn't appear that the bulb has any issues. When we actually touched it, the glass was actually cracked, and probably had been cracked when it was installed and the liquid inside leaked out, or as the heat built up, it seeped out, but it didn't break the bulb, and thus the system did not fire, because this has to open up a valve right here. With that glass in place, it will not open the valve. So why didn't the system, when I didn't mention, was when they discovered the fire, the captain on the boat grabbed the manual firing mechanism, which is right in the helm in the cabin, and pulled it. And again, remember this little tab and this wire. And when he pulled it, this is what he got. That's not supposed to be what has happened. Think of this as your hood release cable or something similar. You know, the secondary, the cable. Anyway, this is not what is supposed to happen. That had no effect, because all it's doing is pulling the whole cable. The metal actual wiring inside of it didn't move, and there was quite a bit of cable inside the engine compartment, so it didn't do anything. So now we can see that when they installed this, the marina drilled a hole to fit and just slide the whole thing in, instead of drilling a hole no bigger than that threaded bushing. And so when everything is in place and they attach the nut and bolt and washer, it is locked in place. And so when you pull on the handle, the wire will move, not the whole assembly. Again, another view. So the cause of this fire we didn't discuss, but the fire was actually, we believe it was an electrical fire, and not all foreign manufactured boats are built to the same North American standards. Research, because of the organization I belong to, IAMI, I found out there were several other boats in the United States by the same manufacturer, and they all had electrical fires in different locations, and it was all determined basically that the wiring was not done properly, and they were shortcuts made, and so that was the center of the issue. The interesting thing was, in this the lawsuit that happened, the manufacturer was sued, and so was the marina in the United States. The marina in the States was invited to attend along with the boat manufacturer, the salesman, and Fireboy, the fire suppression company. All but the marina participated in joint examinations. When it came to mediation, the lawyer showed up from the marina with a report indicating how this fire was caused when they hadn't even looked at it. And when it was pointed out how wrong they were, they ended up being nailed with 75% of the costs of the boat loss. So questions you need to ask: obtain all purchasing documentation, very valuable. Where was it purchased? Was any work done after delivery, and who did the work? So now we go to an arson fire. This is the wrapping it up here. This is an arson fire. The boat was a 1992 24-foot Sea Ray, was in winter storage in a compound. The owner had been on board the boat that day to check on it. And a short time after he left, a fire was discovered. Again, Sea Ray, looking at the fire, you can see the fire is coming out from the cabin area. You can see the engine compartment is intact. Batteries are connected, again, for no reason, but you can there's no fire in the engine compartment. So now we're looking into the cabin, obvious fire, a lot of heat. Again, this fire is self-extinguished, but you can see the effects of the heat. It's delaminated plastic, up high, melted plastic, but you can see the seat cushions here, the bed cushions are all burnt from the bottom, and this is the seat of the fire. very obvious where the fire originated. And again, this fire self-extinguished. Our examination discovered, and the police had seized this, and we've got to have a chance to look at it, this little item. What it was is a plastic bottle with a wick in it. And the plastic bottle contained a flammable liquid. It isn't a Molotov cocktail, but it was being used like a big candle to fuel this fire, initiate the fire. And that's the end of it. Anyways, important to know, this is straightforward arson, but I want to emphasize the importance of something I brought up at the beginning of the webinar. It's important to know when and where the loss took place, the time of year, and the activities of the insured prior to the fire. You need to consider if the boat was found in an isolated area, what time of day the loss took place, whether it happened in the beginning or the end of the boating season. A lot of arsonists are trying to get rid of their boat at the beginning of the season to buy a new one, and for whatever reason it can't sell. We also see them at the end of the season in cases where extensive amounts of repairs are now required in order to make the boat seaworthy again. So they decide, instead of trying to repair the boat or sell it, they'll have the insurance company buy it. So boat owners commonly make their own modifications. They don't always use the proper materials. It's crucial to preserve the scene and evidence. Again, this is a summary of everything we have. When boats are placed in winter storage, always have the electrical sources disconnected. And there's no logical reason to keep the batteries connected on the boats when they're in storage. High risk, no reward. And purchasing a used boat can have risks. Faulty workmanship, improper installation, improper choice of materials used in the installation, or improper choice of equipment used happens quite often. Make sure to get as much information about the service work and the mechanics when receiving a loss. Humans make mistakes, and some have dire consequences. Nature boats having confined areas sometimes is difficult to do the most simple tasks. Human error claims such as this are not uncommon. And not all manufactured boats are built to North American standards. I'm going to wrap it up here. Are there any questions?
Thanks, Rich. Appreciate it. Yes, we do have questions that have come in. Thank you guys for submitting the questions. I doubt that we'll get through them in 3 minutes, but I'll jump right into it. First question, I believe, is relating to the last case study. Would that prompt, not the last case study, I believe the one, the foreign, it says, would that prompt a recall or notice with Transport Canada?
No. Transport Canada, because it's a one, that it happened, I think we had a history of, that I know of at least 3 or 4 boats, 1 in Canada and 3 in the United States, 2 or 3 in the United States. That's not going to prompt any kind of urgency by Transport Canada.
Okay. Next question. Should these battery areas be professionally checked on a regular basis, and if so, how often?
A battery, no, a battery itself is not a problem. It's no different from your car. I mean, your car battery. You don't, yes, your mechanic may have a quick look at it. It's important to clean the terminal posts, make sure they're tight when the beginning of the season, and maybe check them every once in a while just to make sure the connections aren't loose, because it's a wing nut that holds that clamp or that end of the cable in place. But if they're done properly, nothing's going to happen over a year. But
Okay.
again, it's winter storage where it's the issue.
Okay. When the marina winterized the boat, would they not normally unhook all the batteries?
Some marinas do, some marinas don't. There's no standard for that. And as I said, some boat storage places, the owners will do their own winterization and then show up with a boat and turn it over to them. And then the marina, then the storage facility just puts it away. But ideally, they should be, the storage facility should be ensuring that the batteries are disconnected.
Okay, great. One last question, because it is we have hit our time. When preserving the evidence, can an adjuster simply seize the boat, or do we need some sort of authority?
I mean, the adjuster can secure the boat. I don't know if they can seize it, but I mean, it's same as you get a house fire and you put security on it, or you put a secure fence around it, you board it up. If they can, take the boat to a secure area where it can, where access is limited. That's the best, if they can.
Okay, great. Well, thank you so much, Richard, and thank you all for joining. Anyone else has submitted questions that we haven't been able to get to, we will make sure to respond to you as soon as possible. As I had mentioned before, this webinar is being recorded. It's going to be posted on our website, LinkedIn, and YouTube pages. Also, once you close this webinar screen, a few questions are going to pop up. We'd love your feedback on that. So please do fill in that information, and please stay safe, everyone. Thank you all once again.
Thank you.
Have a great day. Thanks, Rich.